Welcome to Dr. Yap Van Ha's Problem Box. In today's lesson, we are going to solve a problem. Let's see what problem we have for today. Today's problem is about a figure. The figure is made up of a square and a rectangle, and they overlap. The area of overlap is shaded. The square's area is 2/5 that of the rectangle. The shaded part, that area is 3/4 the area of the square. The unshaded parts have an area of 72 square centimeters. The question is, can we find the area of the square as well as the area of the rectangle? Also, is it possible to find the dimensions of the square and the rectangle? Which means, can we find the length of one side of the square as well as the length of the sides of the rectangle? That's our problem for today. Let's try. How far are you in solving the problem? Have you managed to get an answer? If not, that's alright. Let's see how we can go about trying to solve this problem. One possible method is to use bar models to represent the area of the square, of the overlap space, of the rectangle. So we know that the square's area is 2/5 that of the rectangle. I wonder what I can use to represent the area of the rectangle. Would this be suitable? If this is the area of the rectangle and the square's area is 2/5 this, can you imagine the model for the area of the square? Is that what you were thinking? Is this correct? If this is the area of the square and this the area of the rectangle, does the model shows the information we have? The square's area is 2/5 that of the rectangle? Is this 2/5 of that? If it is, then the model is correct. Next, the shaded part's area is 3/4 the area of the square. So this is the area of the square, and we know that the shaded part has an area that is 3/4 of this. So it's not so easy to see 3/4 if I represent the area of the square using 2 parts. How many parts should I use? How many units should I use to represent the area of the square so that showing 3/4 is quite convenient? Perhaps using 4 units. And if I use 4 units to represent the area of the square, instead of 5 pieces, how many should I use for the area of the rectangle? Is this a suitable model? The shaded part's area is 3/4 the area of the square. So this is the area of the square. The shaded part's area is 3/4 of this. Can you see which part of the model represents the area of the shaded part? 3 units, isn't it? So that's a shaded part, and this is the unshaded part. How about for the rectangle? This is the area of the rectangle. Which part of the model represents the area of the shaded part? That's right. The shaded part is common to both the square and the rectangle. So if the shaded part has an area of this for the square, for the rectangle, it must be the same area. So for the rectangle, this is the area of the shaded part, and this represent the area of the unshaded part. And we know the total area of the unshaded parts is 72 square centimeters. I think you can continue from here. What's the answer? The square's area is 2/5 that of the rectangle, and the shaded part, the area is 3/4 of the area of the square. And we know that the total area of the unshaded parts is 72 square centimeters. What's important is to realize that the shaded part for the square and the shaded part for the rectangle, they are common. Can you see which parts of the model represent 72 square centimeters? That is right. This and this. 8 units represents 72 square centimeters. So to find the value of this, we can simply do division. So now we know that this represents 9 square centimeters. The area of the square is therefore 4 times that value, which is 36 square centimeters. And if the area of the square is 36 square centimeters, we can find how long the side of the square is. 6 centimeters, isn't it? How about the area of the rectangle? The area of the rectangle is 10 times that value, which is 90 square centimeters. Can we find the length of the sides of the rectangle? Now that we know the area is 90 square centimeters, I don't think we have enough information for that. If you find today's problem easy, you can challenge yourself in at least 3 different ways. One way to challenge ourselves is to say, what additional information do we need for us to find out the length of the sides of the square? Presently, unlike for the square, where we can find the length of the side of the square, which is 6 centimeters, presently, we are unable to calculate how long this is and how long that is. The first way to challenge ourselves is to state the additional information that we need in order for us to find the length of the sides of the rectangle. A second way to challenge ourselves is like so. For this problem, the fractions we have are 2/5 for this part and 3/4 for that part. And the result is that the area of the square is 36 square centimeters. 36 is a perfect square. The challenge is this. If I want the area of the square to be a perfect square, meaning the area can be 1, 4, 9, 16, 25, 36, like in this problem, 49, and so on. If I want the area of the square to be a perfect square, what can those 2 fractions be? You are, however, not allowed to change that information. You must keep 72 square centimeters. That's another way we can challenge ourselves. A third way we can challenge ourselves is this. In the original problem, we were not told about how the 2 shapes overlapped. But what if we know that they overlap in a way such that all the lines are either parallel to each other or perpendicular to each other? Meaning, the square and the rectangle overlap in this way. All the lines are either parallel to each other or they are perpendicular to each other. If we have that information, do we know the ratio of this length to this length? Also, the ratio of that length to this length? Those are some ways we can challenge ourselves. See you next time in another problem box.
I can't forget the day we met. Your eyes so blue, me piercing through. I can't forget the